Good morning, ladies and gentlemen. Today we will talk about one of the most important topic in air navigation, that is a critical point, and how to find out a critical point. So what exactly is a critical point? Let us assume a route from Chennai to Bangkok. If you see, there is a direct line from Chennai to Bangkok, and this particular route is overflying the Bay of Bengal. As you would have realized here in this particular route, you will have very less number of en route alternate. So in this case, I have to determine before the flight itself that a point en route from where it takes equal amount of time to come back to my departure base, that is the home base, that is Chennai, or to proceed outbound to Bangkok in case of any eventualities. This eventualities may be an engine failure, a pressurization failure, you have a patient on board, or any other critical situations. In these situations, I'll have to determine a point where it is fastest to come back. So in order to find out, I need a point which takes equal amount of time. So that point en route from where it takes equal amount of time to come back to my home, that is Chennai, or to proceed outbound, that is to Bangkok, that point is known as the critical point. So it has to take equal amount of time to proceed to destination or to come back to the base. So by definition, the time to come back, that is TH, which is written in the red font, and the time to go outbound, that is towards Bangkok, which is written in the blue font, has to be equal. For this, we will assume the distance between Chennai to Bangkok as D, okay, one in the white font, and let us also assume that the CP is X nautical miles away from Chennai, and it takes equal, the distance from CP back to Chennai is X, and the distance to go to Bangkok will obviously be total distance, that is D minus X nautical miles. And let's find out the time to come back from X to Chennai, that is time from CP to Chennai, that is time homebound, or TH red in font here, is equal to the distance divided by the ground speed home. Distance divided by the ground speed home. So X upon H will be the time taken to come back from CP to Chennai. Similarly, if I have to proceed outbound from CP to Bangkok, that is time outbound will be equal to the total distance minus distance from Chennai to CP, that is X, divided by the ground speed outbound, that is ground speed O. So by definition, okay, TH is equal to T outbound. So let's replace this TH. Okay, TH is, as we have seen in this particular line, that it is X upon H is the time to come back home, and the D minus X upon O is the time to go outbound. Both of them has to be equal. So let us simplify this formula. Okay, if I take this outbound O onto the left side, so it will be multiplied to us. Okay, 2x. Okay, so it becomes XO will be equal to that H into D minus X. So we distribute, it is DH minus DX. So therefore, XO, if we transpose this HX towards the left side, that is XO plus HX will be equal to the DH. So if we take X common, that is X, okay, bracket, O plus H will be equal to DH. So therefore, X will be equal to DH upon O plus H. So this is the final formula to compute the CP. So I say again, this X is the distance to my CP, okay, will be equal to total distance into ground speed homebound upon an addition or the of ground speed out and the ground speed home. So this is the formula you must remember to compute the CP. After having found out the formula, so we will talk about we will take a numerical, that is calculate the distance and the time to CP from Chennai to Bangkok Assume that a distance from Chennai to Bangkok is 1200 nautical miles. Engine failure speed is 300. Here in this example, I am assuming that en route to Bangkok, you have an engine failure. In case of any engine failure, so you want to land ASAP, so therefore I have taken a dash of 300 knots. Winds outbound is a tailwind of 50 knot, and the normal cruising speed without any failure is 270 knots of IAS. On this leg also, you have got a tailwind of 50 knots. You may be surprised that I have taken higher speed for engine failure than the normal speed. This is a chapter on the cruise which I will conduct subsequently. Most of the airliners will fly a speed which is determined after having catered for the fuel consumption and at the cost of the time. We call it as a cost of index. That is cost of time upon the cost of fuel. After having fed this cost index value on your MCDU, you get a speed which is known as the econ speed, which is lower than your LRC speed. Okay, that is the long range cruise speed. And in case of any eventualities, if you want to fly at a faster speed, you will be flying at a faster speed, normally at the LRC. Okay, so therefore I have assumed that here in this particular example a higher TAS value. We will elaborate about this TAS, LRC, econ speed and the MRC or the MMR in some other class in the future. But however, you can take it that the speed normal is 270 knots and the speed after the engine failure is 300 knots. So the ground speed home will be equal to the TAS minus the winds. So it is on the outbound we had a tailwind. So in the inbound we will have the headwind. So 300 minus 50, that is 250 will be my ground speed homebound, and the ground speed out will be TAS plus the winds. So that is 300 plus 50, 350 knots. So therefore the distance to CP, that is X, will be equal to DH upon OH. Therefore 1200 into H is 250, O plus H is equal to 250 plus 350, which is 600. So the value of 1200 multiplied by 250 will be 300,000. Okay, and divided by 600 will be the distance. So if we solve this problem, the X, that is the distance from Chennai to the CP, will be 500 nautical miles. So let's verify whether it is true or not. This is a cross-check which you can do even in the exam also. That is time to the CP to Chennai, it is 500 upon ground speed home, that is 250. So it will take 2 hours to reach back from CP to Chennai. And similarly, from CP to Bangkok, the distance will be total distance minus 500, which will be equal to 700 divided by the ground speed out, which is 350, which is 2 hours. So it proves that it is taking the equal amount of time to come back from CP to Chennai or to proceed to Bangkok. So even in the examination also, if you want to verify whether your exam answer is right or wrong, you can verify with this simple formula. So now let's find out the time to the CP. So here in this case, as you are proceeding outbound towards your CP, you will be cruising at a normal speed. Okay, in case of any eventualities, then only you will decide whether to come back or to proceed ahead. In this case, if you have to decide to come back or to proceed ahead, in case of any failure, you will take the engine failure speed or the pressurization failure speed or any other speed which you have decided in case of any passenger or any other critical emergencies. So this will be very critical as we go ahead and talk about the EDT also, that is extended diversion time operations. So therefore the ground speed, okay, under normal cruise will be the normal cruising task. Okay, since we have got tailwind on the outbound, so I have added this, so ground speed will be 320 knots. So therefore the time outbound will be 500, which is the distance to my CP, divided by 320, which is 1.562 hours, which converted into hours and minute will be 1 hour 34 minutes. So therefore, the time to reach my CP under normal conditions will be 1 hour 34 minutes. So after having solved that numerical, we will do a little bit of change in that previous numerical. So departure and destination airport remains the same, that is from Chennai to Bangkok. And the total distance is 1200 miles. The speed remains the same, 300 knots. But here in this case, the winds had been reversed. So earlier in the previous example, the winds outbound were tailwind of 50 knots. So I have taken a headwind of 50 knots. And the normal cruising speed remains same, that is 270 knots. And here similarly, the winds outbound were tailwind in the previous example. So in this example, we will assume that the winds outbound is headwind. So the winds had been reversed. So the ground speed home will be, in this case, will be since it was a headwind in the outbound, so I will have a tailwind in the inbound. So therefore, the winds home will be 300 plus 50, 350 knots. And similarly, the ground speed outbound will be 300 minus 50, which is 250 knots. And with the formula, that is CP is equal to dH upon O plus H, that is 1200 multiplied by home, in this case will be 350, divided by the sum of 250 plus 350, which is 600. So 420,000 upon 600, which is equal to 700 nautical miles. Okay, if you recollect that the answer has been reversed. The distance to now from Chennai to CP is now 700 nautical miles. Let us verify once again like the way we did earlier. That is the time to CP to Chennai will be 700 upon 350, which will be 2 hours. And the time to Bangkok from CP will be 1200 minus 700, which is 500 upon 250, which is again 2 hours. So they are taking equal amount of time. So if you look at this, okay, what is happening is that in the previous case, when I take earlier, the distance was how much? The distance was to Chennai. That is distance from CP to Chennai, okay, which is equal to 500 with tailwind on the outbound, that is 50 knots, okay, was here. Okay, and in the second example, the distance from Chennai to CP, okay, with 700 knots, that is headwind of 50 knots in the outbound. So what has happened in the previous case, since I had the tailwind on the outbound, okay, the CP has moved, okay, closer to Chennai. So in a normal case, when you do not have any winds, which is very, very rare, the CP will lie exactly at the midpoint, that is midpoint between Chennai and Bangkok. So in the previous example, when I take a tailwind of 50 knots, the CP has shifted towards the wind. It has gone windward. So in the second example, when I take the headwind onto the outbound, the CP once again has shifted towards the headwind. So we can have a conclusion that the CP will always move into the headwind. So on a condition that when the winds are calm or winds are zero, the CP will lie exactly midway between the Chennai and the Bangkok, okay, your departure and the destination, and the CP will move towards the wind, that is the headwind. Okay, so this is one conclusion. So in this case, the time to calculate to the CP will be the normal cruising speed of the aircraft, which is 270. On the outbound, I have a headwind, so therefore my ground speed will be 220 knots. So if I have to find out the time, will be 700 upon 220, which is 3.18 hours, which when converted to minutes and hours, it is 3 hours 11 minutes. So the time from Chennai to CP in this example will be 3 hours and 11 minutes. Okay, you can do this at your home. The distance between the departure airport to destination is 900 nautical miles. Normal cruising speed is 300 knots with 30 knots of tailwind at the normal cruising level. Calculate the CP for pressurization failure case. Assume that you are cruising at flight level 100. The task for pressurization failure at flight level 100 will be 250 knots and the winds at 500 at 100 flight level 100 will be tailwind of 10 knots. So we will verify, or you can send me your answer onto the comment box so we can verify it in my comment, reply to your comment. So next class I'll be taking up the numericals of a multiple leg CP or a CP on a straight leg with a different winds and route. Thank you, ladies and gentlemen. Have a nice